Column chromatography. So basically, this is used for purifying an organic compound. We're packing a glass column with a slurry of an absorbent material, for example, aluminium oxide coated with water, stating this is the stationary phase. The mixture is then to be separated, is added to top of column, and drained in the slurry. And the solvent is then run slowly and through the column, and this is the mobile phase. The solvent is the mobile phase. And then as the mixture is washed through the column, the components separate out according to how soluble they are in the mobile phase and how strongly are they absorbed into the stationary phase. The more soluble the component in the mobile phase, quicker it passes through the column. In gas chromatography, stationary phase is solid coated by viscous liquid packed into a long tube. Tube is coiled to save space and built into an oven. The mobile phase is unreactive, will carry a gas, for example nitrogen. Each component takes a different amount of time from being injected into the tube to being recorded at the other end, and this is retention time. Retention time depends on how much time the component spends moving, along with carrier gas, nitrogen, plus how much time is spent stuck to the viscous liquid. And gas chromatography is used to separate out a mixture of volatile liquids. So the reason I say this is because you could get maybe a possible one marker, tick a box kind of question. Not a multiple choice question, tick a box kind of question. So it may be on paper 1 or paper 2. It'd be like, state which chromatography is most appropriate, and it'd be like the student is purifying an organic compound, column chromatography. The student is trying to separate out a mixture of volatile liquids, like a gas, the molecules separate out. You're trying to separate out a mixture of volatile liquids, and you're thinking, okay, gas chromatography instead of column chromatography that's used to purify organic compounds.